Hi everybody, welcome to our section 5.4 video lecture on multiplying signed decimal numbers. Alright, so first thing we're going to do is a little refresher from chapter 1 about multiplication of signed numbers. So if you guys remember from chapter 1, a positive number times a positive number gives you a positive number. A negative number times a negative number also gives you a positive number. This is like facing the negatives and hopping backwards. It actually puts you in the positive direction. If you have a positive number times a negative number, that gives you a negative number. And if you were to switch that around and do a negative number times a positive number, that also gives you a negative number. So how do you multiply decimals? So if you were to do this with calculator, you would multiply normally. You would, you actually don't line up the decimals. You just multiply normally and have them one on top of the other. And the number of the decimal places in your product, that's the answer to a multiplication problem, is the same as the sum of the decimals before you multiply. So what I meant by that is, like in example A, you have 1.7 times 0.6. You have one decimal place in 1.7 and one decimal place in 0.6. So the sum would be 2 decimal places total. So my answer is going to have 2 decimal places. In B with the 8.5 and the negative 1.87, 8.5 has 1 decimal place and 8.7 has 2. So the total would be 3. So my answer is going to have 3 decimal places. Okay, so if your decimal place doesn't work on your calculator, or if you do it by hand, that's how to find where the decimal place goes. Okay, so let's do some examples. So for each one of these, we're going to go back to some front-end rounding. And we're going to do front-end rounding to estimate our answer, because you don't always have a calculator handy. It's good to know how to estimate answers. And then we're going to find our exact answer. Okay? So my first one I have is 1.7 plus 0.6. So you guys remember front-end rounding, you round the very, very first number. So in this case, it would be the 1. Over to the next value here would be a 7. 7 rounds up, so this would round to 2. Times, with the 0.6, we're rounding the 0 in front. The 6 to the right of it would round up. So it'd round up to 1. So for my estimate, I'm doing 2 times 1. 2 times 1 is 2. So my estimate is, it's going to be around 2 for my answer. The exact answer, you can type it into your calculator if you'd like. 1.7 times 0.6. And you're going to get 1.02. So this is less than 2, but it's pretty close actually. If you think about it, we rounded both of those up, so that estimate is going to be bigger than our exact answer. Alright, for part B, I've got 8.5 times negative 1.87. Alright, so estimate for the front-end rounding of the 8.5, I'm going to round by 8. To the right of it is a 5. 5 is bigger, so it rounds up to 9. For my negative 1.87, I'm rounding the 1 in front. To the right of a 1 is an 8. 8 is also a bigger number, so it rounds up. So that would round up to 2. It was negative and it stays negative. So we're doing 9 times negative 2. 9 times negative 2 is negative 18. Alright. The exact answer, you would do 8.5 times negative 1.87. You guys shouldn't have a minus key on your 4-function calculator. So you're just doing the digits multiplied by each other, and you would get 15.95. And then you would have to think, is it going to be positive or negative? Well, we have a positive number times a negative number, which gives you a negative number. So our answer will be negative, just like our estimate was. All Are you guys about ready to try one? Good. We'll split it up into pieces here. So in part C, take a second and just see if you can round both of these values. Do the front end rounding and round both of those values. And we'll see what you get here in 3, 2, 1. The negative 2.003 rounds down to negative 2. The negative 6.9 rounds up to negative 7. How'd you do? Alright, now for the estimate, you would do negative 2 times negative 7, which would be 14. Now, is it going to be positive or negative? You've got a negative times a negative, which would be a positive. Alright, in your calculators, go ahead and type it in. Do 2.003 times 6.9. We know that it's going to be a negative times a negative, which is going to give us a positive answer. And hopefully you're getting 13.8207, which is pretty close to 14. Okay. Last one. I'll let you guys do this one all on your own, okay? So pause your video, see if you can do the estimate, and then see if you can do the exact number. Okay? So pause your video, and I will show you guys the answer here in 3, 2, 1. For the estimate, you should be getting negative 450. So when you round it up top, you should get negative 50 times positive 9, which would be negative 450. For the exact answer, you should be getting negative 482.46069. So if you notice, the first number had 2 decimal places, second number had 3, so in total we have 1, 2, 3, 4, 5 decimal places in our answer. In case you're wondering why this one was so long. Alright, next up, let's do a little bit of an application problem. Alright, Elizabeth signed up with a new internet cable provider, and they have a 2-year agreement. You guys have maybe done this before. She has an introductory rate of $68.99 per month for the first 12 months. So for the first year, it's going to be that price. Then the price increases to $89.99 per month for the next 12 months. So this is what they do, is they give you an introductory rate. It's a little bit less expensive. Then the price goes up the next year. And then after that 2-year agreement has ended, the price increases again to $112.91 per month. There's also a one-time installation fee of $90. So that installation fee, by the way, you pay that at the beginning. That's how they install the internet and cable to get you started. So part A says, how much will Elizabeth pay for internet and cable for the first year? So the first year, she is paying $68.99 per month, and each year has 12 months in it, so we're doing $68.99 times 12 to see how much she's paying for that first year. She also has that one-time installation fee of $90, which is going to happen in that first month. So we're going to multiply these together, and then we'll add $90 for that installation fee. And that'll tell us how much she's paying for internet and cable for that first year. So if you type that into your calculator, you do 68.99 times 12. Then you take that number and then add 90 to it. She's going to pay $917.88 for the first year. Alright, how much is she going to pay for internet cable for the second year? Well, let's see. It says then the price increases to $89.99 per month for the next 12 months. So that's that second year. She's paying $89.99 per month. There's 12 months in the year. There's no installation that's going on that year. So it's just multiplication. So you do 89.99 times 12. And you'll get $1,079.88 for cable internet for that second year. Alright, I'll let you guys try this last one. How much is she going to pay for each year once that 2-year agreement has ended? So find that rate, and then you're going to multiply it by all 12 months of a year, and see how much she pays for each year afterwards. So go ahead and pause your video and try that one, and I'll show you the answer in 3, 2, 1. Should be doing $112.91 per month times 12 months. So for each year after that agreement has ended, it's going to be $1,354.92. How'd you do? Good. And now you guys know how to calculate internet cable prices. Pretty exciting, and definitely applicable to real life. Hope this set you guys on a good path for the week, and have a great week, guys.